This call is now being recorded.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So we'll meet again in this lecture about programmable logic controller. And this time we will learn about many different applications using programmable logic controllers, especially in automatic shoemaker and also inspecting label using the PLC. Okay, so according to what I say previously, after the mid-semester examination, there will be a change. So we are no longer learn about syntax anymore. We just want to see many different applications using PLC, so you can grasp the idea of using the PLC in the real world. Because it's no longer about pressing the right push button in order to make a certain output active, but it's more about to apply the program in the real world in the automation system. Okay, so without further ado, let's see our first system, automatic shoemaker. So if you already know that shoemaker is one of the most famous Formula One driver, but it is not about that person. It is not more about the shoemaker itself. So imagine that you are in the industry, and that industry consists of many shoemaker. You can see it here that there are many valves, but in this case we only have two valves, valve 1 and valve 2. Valve 1 is almost has the same function with the valve 2, and we can imagine that there is material that is carried out here into the tank. So we control the amount of the material that we want to put inside the tank. And inside the tank, there are three different sensors: low sensor level, middle sensor level, and high sensor level. And every sensor has different input address. So you have to put it in your mind that every sensor consists of different input address. It doesn't have to be a certain address. For example, for sensor level low, it doesn't have to be %i0.0. It can be anything between %i0.0 until %i0.7 in this case, or maybe 8, because we have 9 address for the input. So we can imagine that the material is carried out, and we can control it using the valve here between the valve 1 and valve 2. Why we have two different valves here? Because we have two different materials that we want to put inside the tank. And then we want to mix it using the stir. So in this system, which is the shoemaker system, we want to combine two different materials, and then after that we stir it, and then after that we want to heat it. So you can imagine that this is something that is maybe fluid, because we can mix something that is already in a fluid, or maybe has a great viscosity. So the material 1 will be carried out using this pipe, and we control the amount of it using the filler valve 1. And for the material 2, also carry it using this type of pipe. So we have two different pipes here with two different valves, valve 1 and valve 2. And then we mix it up in this material tank. After we mix it, we want to stir it. And we want to balance the amount of the material here. So we have to make sure that the amount of each material is the same. And how do we do that? By using this middle sensor level. So based on the equation here, we can see that when the start button is pressed, the system starts to function by first opening the fill valve 1 and starting to fill material A. So when we press this push button, the valve will open. Okay, the valve will open. Okay, this is filler valve 1. So the material will be put here inside the material tank. And then after we open the valve 2, the material here also will be put here. So first, the material A will be put here until the middle sensor level is active, which means that when the middle sensor level active, the material A is already here, filling the tank. So during the time, we stop the flow of the material A. Why? Because it already reached its maximum value. So after that, after we stop the material A, then the filler valve 2 will be open. And after that, the material B will be put inside the material tank, which means that in order to do that, the filler valve 2 must be active. And when the material B reaches its maximum value, which is indicated by the activation of the sensor level high, the material B will be stopped to be put inside the tank. So it means that the tank consists two different materials. The first one, the material A, will be filled until it reaches the sensor level middle or middle level sensor. And the second material, material B, will be filled until this tank is full, which indicated by the activation of the sensor level high. And after both material already inside the tank, the stir will be active. So the material will be mixed. Okay. So you can imagine that we basically just want to mix two different materials inside the tank. The material that we want to use to create a shoe. Okay. And then what happened after that? Yes, when the material is full, the filling and stirring process will stop. The heater begins to function to heat the material so that it can be printed, or I just want to mold it. Yeah. So in this simulation, we only heat the material for 10 seconds. Even though maybe in the real world, in the real industrial process, it must be more than 10 seconds. Because it doesn't make any sense that the process can be operated within 10 seconds. It doesn't make sense after all. But we just want to simulate the real process using the program, and we just simulate it in 10 seconds. Okay, so what happened after that? After the heating for 10-second simulation, so we start the printing. So we start to fill the material inside the mold area, the box. Okay, so it takes 5 seconds to to fill the mold here, and after it full, which is indicated by the timer, and we want to limit it only for 5 seconds, the conveyor will be active. Okay, the conveyor will be active, and the box consists of the material that we already printed before will move. until it reaches the position sensor. Yeah, until it reaches the position sensor. And after that, the conveyor will be stopped. And then we cool the material inside the box using the cooler. Why? Because we can imagine that the material here is already hot enough and we want to cool it using the cooler here. Okay. And then what happened after that? What happened there after that is that we fill the mold again, the box again, using the material that already heated before. And then the process continue. The box will be carried by the conveyor until it reaches the position sensor. And it will also continue and continue and continue until the material inside the material tank is empty, which is indicated by the activation of sensor low sensor level. And then the process will be repeated again. So our task is here to make that happen using the program that we have to design before. So we have to imagine the system, how to make it work properly, and after that we create the program based on the system in order to make the system work properly based on the purpose of creating the shoemaker. So this is how to make it work. So we can see from the program here. But before that, you have to define all the input and the output that are being used here. And I already give it to you. I mean that in a very normal situation, in the real task, you have to define it by yourself. But in this practice, I will give you the list of all the inputs and outputs that we used here. So the input 0, which means it is actually for the address %i 0.0, it will be given to the address for the start push button. The input 1 for the stop push button. The input 2 for the sensor level low. The input 3 for the sensor level middle. The input 4 for the sensor level high, and the input 5 for the sensor position conveyor. Okay, so the position sensor for the input 5. I just want to make some adjustment here. Okay, position. Okay. And for the output, we also have 6 different output that we can use here for starting. The 0 will consist the output for filling valve 1. The 1 will be given to the address for filling valve 2 and steering. So filling valve 2 and steering is given the same address. It is actually something that can be created in the real world, but it's not something that's very ideal. Why? Because usually different output must be connected to the different address. But in this case, okay, because filling valve 2 and steering usually work at the same time, so it is no problem. We want to make it work in the same time. It's okay in this case. Okay, for the output 2, it will be for the heater, and the output 3, it will be separate valve, and the 4 for the conveyor, and the output 5 for cooler. So we have 12 different, actually 13, because we put the filling valve 2 and steering at the same address. So it's actually, we have 13 different I/O, but we want to make it simple, so we only use 12 different I/O for the system. Okay, so we can imagine that based on the algorithm that we created before, when the push button start is active, the filler valve 1 will be active. And of course, we can imagine that when we release the push button, it's still active. Yeah, we don't want to press it all the time. We only want to press it in the very beginning of our program, our automation system. So we don't have to press it to make it happen again. We just have to press it, release it, and then the system will work. Okay, so because we already defined the input 0 for the push button, we can give the address here I00 as the address for push button 1. Okay. Everyone here? So we want to associate the symbol PB1 with the percent I0.0. Okay, so we already know that if we want to make something keep happening, so we have to latch the output or to make self-holding. And the easiest way to make a self-holding is by using the set output here. Okay, so we can see that in this output, we can use the output 0 for the filler valve 1. Okay, so the filler valve 1 will be active. The output is percent Q0.0. This is the filler valve 1. Okay, so this is a very simple program. Yeah, this is the simplest program that we can create here. So we can imagine then in this case, when the push button 1 is pressed, the filler valve 1 is active. And what happened after we release the push button 1 is still active because the situation or the condition of filler valve 1 is depends on the activation of the middle sensor. Okay. The activation of middle sensor. Okay, so we add another rung here. I can imagine that we press this push button in a 0, it will open, filler valve 1 will be open, and the tongue will be filled with the material A until it reaches the sensor level middle. Okay, so we can imagine that when the middle sensor is active, percent I0.3 middle level sensor. Okay, we give the address. And then it will make the filler valve 1 inactive. And the easiest way to make that happen is by using the reset output here. So the reset output will be connected to the filler valve 1. But middle level sensor is also activated the filler valve 2. And it also activated the steer output at the same time. So it's okay. We just make a parallel output here, okay, by giving the output for filler valve 2 and also the steering. Filler valve 2 and steering, but we don't have to define the steering yet. So when the filler valve 2 is active, the steering is active. We just want to make it simple. Okay, so we can imagine that after the sensor level middle is active, it will stop. The filler valve 1 will be stopped, and the filler valve 2 will be active, and the steering is also active. And it will stay in the same condition after until the both material reach the high sensor. So after that happen, the filler valve 2 will be inactive and the heater will be active. Okay, so it's basically a very simple, straightforward program that we can create here. Okay, so yeah, we have to define the address again. Input 4. Okay, input 4. High level sensor for the address of I0.4. Okay, so after the material is filled inside the tank, which is indicated by the activation of the high level sensor, the filler valve 2 will be inactive. Okay, so we just make this thing inactive again. Okay, so this is for the heater, but we just want to make filler valve 2 inactive. So we can see it here, a filler valve 2 is inactive here. Okay, and then at the same time, we activated the heater. Okay. And the heater is activated just for 10 seconds. And why? Because we only make the simulation here. Maybe in the real world, it will be activated for 30 minutes, for example. It is more makes sense. But because we just want to make simulation here, we simulated it will be active for 10 seconds. And we have to find the real or maybe the most suitable timer that we can use here. I0.4 for a high level to activate the heater. Okay. To activate the heater, which is okay. We use timer here, and we can pick 3 different timers, and we have to define what kind of timer that is best fitting for this system. And of course, because we want to limit the time that we want to use to make the heater active, it will be the most, the most suitable situation if we choose the pulse timer. Okay, so we choose the pulse timer here to active only for 10 seconds. 10 seconds. Okay, and of course this will be for a non-retentive timer. And the output will be connected to the heater, which address in Q0.2. But in the real world, maybe 10 seconds is not enough. It must be between 30 minutes until 1 hour, you can imagine. Okay, so the heater will be active for 10 seconds in this case. Okay, so we can imagine what happens to roughly. So I just want to mention it again. When we press the Okay, so this is a technical problem here. Okay, we can continue again. Yeah, fortunately, I can hear myself, so I will know whether there is a problem or not. Okay, so we will be back again. I just want to make some kind of review for the system. So when the push button start is pressed, the filler valve 1 will be active and then it will open. And of course, at the same time, the material R will be filled inside the material tank here until it reaches the middle level sensor. And in that case, the filler valve 1 will be inactive again, will be off, and of course, it will stop the filler of material A. The material B will be filled inside the tank and the stir is also active at the same time until it reaches the sensor level high, which is indicated by the activation of input 4. So after that time, the heater will be active for 10 seconds. Okay, so we already reached the situation when the heater works for 10 seconds, and then the separ valve will be active. Okay, the separ valve will be active for so for 5 seconds in this case. Okay, so we want to make the separ valve active. So we can connect the high level sensor again. Yeah, the high sensor again to connect to the set of a certain internal address. And then we connect that certain address to on delay. Why we have to keep the address active? Because we can imagine that the high level sensor will be inactive as soon as the material is decreasing. So you can see it here. In this case, when the material is emptier, because whenever we put something here inside the mold or box, the volume of the material tank will be less and less. Okay. And in this case, the sensor level high will be inactive. So we have to keep the sensor level high to activate something. So we have to keep certain output to be active. And of course, the easiest way to make that happen is just to connect the high level sensor here to a certain memory address, internal in this case. So it will keep active no matter what the condition in high level sensor. So we can see it here that the address for the percent M0 will be keep using the set syntax. Okay, so we can connect the memory address again, the internal memory address again with the internal timer here. And in this case, it will be better if we use the on delay timer. So we can use it for also 10 seconds. It will be the same time required in both cases, using the preset timer and also using the on delay timer. So after 10 seconds in this case, then the material will be filled inside the box, yeah, that already heated before. So after 10 seconds here, okay, so the address we use percent TM1. Okay, so we can see it here again. It will put it will be put inside the box for 5 seconds. Okay, for 5 seconds. So it will be something that is always repeated again and again. We connect it to M2, and then we connect the M2 here. And we fill the box in 5 seconds using, of course, the pulse timer. This is the type of timer that is best to be used in this situation. Okay, 5 seconds then, and then after that, the conveyor will be active. Okay, maybe I'm sorry. Maybe we can use the on delay timer instead. Yes, after 5 seconds, the conveyor will be active. So we have to see the address for the conveyor again, which is out 4. Until it reaches the position sensor, which is input 5. And after that, we reset the conveyor. And at the same time, we activate the cooler for, I don't know, we can see it here. Is there any mention for that? Okay, also 5 seconds. The cooler is output 5 or separate valve. So we can actually define how the separate valve work before that, because maybe I forget to to activate the separate valve here, but it must be activated here in this rung. So we can insert rung here. So M2 also activate the separate valve. Q0.3 separate valve. M2. So M2 here will activate two different situations. The first one is that it will make the separate valve work for 5 seconds. Okay, for 5 seconds. And also, it also makes the activation of the timer on delay. And after 5 seconds, exactly, the output conveyor, which is indicated by the output key 0.4, will be active. So actually, the program doesn't have to be exactly in this order. Maybe you can create a more simple program, a simple program in this case. But this is one of the example of how to make the program work. Okay, so we make the conveyor work until it reaches the position sensor, which is indicated by the percent %I 0.5. So we have to put the mention here, position sensor. I'm sorry, this is must be percent %I 0.5. And then it will activate the cooler for 5 seconds. Cooler, in this case, the address is percent %Q 0.5. And it will be active for 5 seconds. You can cut 5 seconds. And then it will reset. And then we will repeat it again, which in this case, we activate the separate valve again. And the separate valve will be activated by using percent %tm4.q. Okay, maybe we have to make additional program here. We create M3 here. Okay, so why do I make that kind of program? Because it must be repeated again. The program must be repeated after the cooler is active. Okay. After the cooler is active, the program must be repeated, so the separ valve will be active again. So we can activate the filler, I'm sorry, the separ valve for two different situations. The first one is when the high level sensor is active, and then it will activate the M0. M0 will make the activation of M2, and M2 will also activate the M3 here. And then we can see it here that everything starts for the activation of the M3. Okay. When M3 is activated, when M3 is activated, then the conveyor will be active after 5 seconds. Okay, so we can see here that M3 can be activated when the M2 is active or when the TM4 is active. And after TM4 is active, it will activate the M3. So the M3 will make the separ valve active for 5 seconds, and 5 seconds later, okay, 5 seconds later, it will activate the conveyor here. And then we have to think about the situation when the low sensor is active. Okay, why? Because when we activate the output, yeah, we activate the separ valve here, the volume of the material will be reduced until it reaches the sensor level low. When it reaches the sensor level low, everything will be start again. So in order to make it happen, we can just activate the filler valve using the valve sensor level low here. Into. Okay, and after it active, everything will be the same again. Everything will be repeated again until the higher level sensor is active. The M0 will be active. Actually, it will be safer if you set here, but we have to reset it here. Okay, so if we want to make the program again, we can see it here that when the push button is pressed, push button 1, the filler valve will be active. It will stay active until the middle level sensor is active, and during the time filler valve 1 will be inactive, and the filler valve 2 and also the steering is active. Until the high level sensor is active, the filler valve 2 will be stopped active. And when the high level sensor is active, it will activate the preset timer. And okay, so this is the heater. Okay, it will activate the heater for 10 seconds. After the heater actives for 10 seconds, okay, which also indicate in this situation with M0. Okay, we have to reset M0 here. Everything that is set must be reset. That's the number one rule. Okay, so when M0 active, it will active the timer on delay for 10 seconds, and after that it will inactive the M0, and after the 10 second here, M3 will be active because M2 is connected to M3 here. M3 will be active and it will activate the separ valve, and 5 seconds after it's active, it will activate the conveyor and also resetting the M3 here. The conveyor will be active until the position sensor is reached, and during the time the conveyor will be inactive, so the conveyor will be stopped, and the position sensor will also activate the cooler here, so the cooler will be active for 5 seconds also. And after 5 seconds, everything will be restarted again from the separ valve here, and it will continue working until the low sensor level low here active, and during the time we make the filler valve 1 active. So it will always repeat it like this again. Everything must be repeated something like that again and again and again and again. And now we want to stop the process, and it can be very easy. Yeah, the stop button. We can use the stop button here. I0.1, and it is resetting everything. Filler valve. So that is how we create the program based on the situation here. Actually, it can be simpler if we put the stop button in the above, but yeah, it can also create it this way. Okay, so that is for the first task, the explanation for it. I hope that you all understand, and then I will give you the second task. This is related to the box label inspection after this. Okay, see you again. Assalamualaikum warahmatullahi wabarakatuh.